is solving security's big data problem. Our next speaker is a senior market strategy manager at Cribble. She specializes in data analytics and big data. Her career has taken her from Wall Street to Silicon Valley. Please help me welcome Jackie McGuire.
Thank you. Hello. Thanks for having me. I'm Jackie McGuire. I'm going to give you guys a little bit more background because I've had a really interesting career. So I applied for the wrong job when I was 20 years old, living in my car, and I accidentally became a stockbroker for Fidelity 3 years before the entire market imploded. So I started my career as a stockbroker, and from a very young age, what I realized is that people were making really bad decisions, and they were making really bad decisions with their money at this time for a number of reasons. One of them is what we refer to as asymmetry of information, right? So there's more information on one side of an equation than the other, so people don't make well-informed decisions. But the other thing was that even if we gave people good information, without context and without the right processes in place, they were still making bad decisions. So as I progressed through my career, became an economist, started managing cash for a lot of the tech companies in Silicon Valley with SVB, don't throw anything at me. I realized that large companies were making the same mistake, right? So going through the financial crisis, there were actually several tech companies who went bankrupt because they invested their cash that was intended to pay their bills in risky investments that became illiquid. So when I had a quarter-life crisis and decided that I wanted to learn how to write Python, data science seemed like the next logical step because I already kind of understood statistics, and I wanted to understand how to help people make better decisions. So how do we look at data in different ways and explain data in different ways to help people make better decisions? So that's how I ended up here. All right, so the way I got into security is I went to data science boot camp. And at the end of my data science boot camp, I created this model where I took 1 million book cover images from Amazon and I analyzed them and then associated the analysis with the book's rating on Amazon. And I created a model where you could literally judge a book by its cover. So if you had a prospective cover for a book, you could upload it and we would tell you, hey, this is a shit cover. Lucky for me, the data architect at a SIM startup saw that, and he reached out and said, hey, we're looking for an entry-level data scientist, and we're really trying to look at security data differently. So we're looking for somebody who can come in with kind of a fresh set of eyes and look at data in a new way. And so when I got to security, where we were at is we had kind of gone from this strategy of we'll keep everything out, right? So we'll have a firewall, we'll keep everything out, and so that'll take care of most of the threats. And then if things get in, we'll have antivirus, and that will detect the things, and that will help. And so we were missing a lot of threats because they were going around firewalls, they were going around antivirus, and they were hiding between the machine and application layers and in bash history and all sorts of fun things, right? So as technology is wont to do, we innovated. And the technical term for what we now have is clusterfuck. So we have piecemeal solved a whole bunch of different problems, and a lot of these have really become features that have turned into products, right? So we now all have these crazy tech stacks that have all of these different applications that each seem to solve one piece of a problem, but don't actually solve the problem as a whole. And so now, instead of missing threats because they're going around our antivirus and we're not seeing them, we're missing them because the latest statistic that I saw is 23% of alerts from a SIM are actually triaged any given day. CISOs, on the other hand, estimate that 85% of their alerts are being triaged on any given day. So there is a massive disconnect between what's actually happening in the SOC and the impression that we have of what's happening in the SOC. And this problem is getting worse, and thanks to COVID and remote work, overnight, really this problem increased exponentially, right? We're rapidly approaching 50 billion connected devices. We had to go to a bring your own device universe, even if we didn't want to, because overnight everybody had to start working from home, and each of these devices is producing a steady stream of data that we now have to deal with. And so what this has really led us to is 3 kind of big data, big security problems. The first one, and I think Not the one that should be driving most of our decisions, but we all live in the real world. Data you can't afford, right? So one of the first things I did as a data scientist is I got on AWS and I was like, all right, we're looking at syslog, so I'm just gonna pull as many syslog entries as I can. Yeah, believe it or not, in one lunch hour, you can run up like an $80,000 AWS bill if you accidentally query too many JSON dictionaries. Fun fact. They were cool, they reimbursed it, to their credit. But yeah, so a lot of times we're dealing with data that we really can't afford. So we would all love to have every log that is generated by every piece of equipment in our tech stacks in our sim. That's not reality, right? And so I see people handle this a number of different ways. A lot of times it's an all or nothing decision. Either we're gonna put this in our sim or we're not, right? Even better, we're gonna put it in our sim, but come like the 26th, 27th of the month when we're starting to bump up against our license cap, we're just gonna turn these logs off. So any of you who hang out at DEF CON, guess when the best days of a month are to hack an organization? Probably the 27th, 28th, 29th, and 30th, because they probably have turned off their DNS, their VPC, all of their really noisy logs that nothing's going wrong, so we don't technically need them. The reason that I ended up at Cribble is because I have a personal hatred for regex. I forget how to write it literally the second I stop using it, because when I became a data scientist, I was like, oh, I'm gonna write all these great algorithms and I'm gonna spend all of my time, creating these complex models. Yeah, no, I spent my time beating my face against regex expressions, just trying to get syslog into something I could understand. And I think this is most of our reality, and most of us are handling this with regex, we're handling it with Lambda, we're handling it with a lot of one-off processes that are extremely error prone, right? So you have an engineer change one thing in a Windows log, and if you're using a manual regex to parse that log out, it's probably gonna break. So then the second issue that I ran into was data that I couldn't use. One of my favorite things in the world is timestamps without time zones. I don't know what they're good for, but they seem to exist a lot in the ether, right? And so what I also realized is that if you don't create an image in time when you collect data, and a lot of times this is being done after the fact. So if you don't create this image in time and say, where is this IP located today? A lot of people don't realize your sim generally does things like threat enrichment on query. So if I'm trying to look at data that happened 3 months ago, and I'm like, okay, 3 months ago we had an issue, this endpoint was compromised, where is this geo IP location? Most sim, if you have not ingested that geo IP location when you ingested this log, they're gonna give you today's geo IP location. That is completely useless. So what you need to do is create points in time. And so this requires a lot of things, and to be able to use this data, it requires standardizing across things like time zones. And believe it or not, just because a firewall lives in New York doesn't mean it needs to be on Eastern time, which is something that I found out. And then lastly, so this is something that almost everybody, when I say I'm a data scientist, wants to talk about generative AI, right? I think it's top of mind for a lot of us right now because everybody's trying to introduce large language models into the enterprise. So data you can't see, I think, is going to become one of the largest challenges in security. Because when you think about things like data lakes and large language models, they're only as good as your ability to find the data within them. And we have reached the point where our ability to generate data has completely outstripped our ability to analyze that data. So we really are past the tipping point of being able to only deal with data we can see and only deal with data that we can see on the way in. We are now going to have to start dealing it with on the other side, and it's now going to be a lot of data comes in and you can't really look at it on the way in, so it's going to come down to your ability to query that data and to find and remove things from that data that should not be there or that you no longer have a license or a right to use. One of the areas that we see this a lot is in incident response, right? So when I'm dealing with a compromised user account and I have escalated privileges and I'm trying to figure out all of the different things that this user touched before I shut their account down, if you are, like a lot of us, dealing with massive amounts of tech debt and you have multiple different systems that have come in managing users, they probably all have different naming conventions, and I'm sure all of you went through and meticulously overhauled all of these before you just started dumping logs into a SIM, but you would be shocked to find out that that doesn't always happen. So when you don't have data fidelity on the way in, it's going to come down to your ability to query data. And then my last pitch for why we need to start doing a better job of managing data from a security perspective is that as of 2020, the cloud now has a larger carbon footprint than the airline industry does. A single data center, and keep in mind, most campuses are 8 to 12 buildings. I happen to be married to somebody who builds these things. Uses the electricity equivalent of about 50,000 homes and the water equivalent of about 250,000 homes. So being more efficient with our data is also an environmental imperative because we can't just keep building data centers forever. So what do we do about it, right? So this is what brought me to Cribble. So really what we have right now in security is generally you have this one-for-one relationship between your data sources and destinations. So each of your SIM, your NAT, all of your different endpoint detection, network detection, they're each using their own agent. And it's this kind of one-for-one relationship where there's a black box where you're collecting data and sending it and you don't really have a ton of control over it. So here's the concept behind Cribble. If you're dealing with a box of Lucky Charms and you, like me, don't really like cereal, but you do really like sugar, there's not really a lot of sense in paying to put the entire box of Lucky Charms into your SIM if really all you need and all your SIM is going to look at are the marshmallows. So Cribble is this concept that if we separate out the good stuff beforehand, we get more return on the investment for the things that we're putting in our expensive analytics platforms. The rest of these things, those things, the noisy logs like the DNS, the VPC logs, approved internal traffic, all of these things that really you don't actually need these logs unless there's a series of unfortunate events, those can go in object store. Because thanks to a feature called Cribble Replay, you can actually use object storage as a source for Cribble. So if you say, okay, we stopped analyzing VPC flow, we weren't analyzing our VPC logs, but it turns out we actually have a compromise between cloud regions, you can actually point Cribble stream at your object storage, pull the data back out of it, and pay to put it through your SIM. And this prevents you from having to make that all or nothing decision that I'm either gonna pay for this data in my SIM today or I'm never gonna get it. So this is what that looks like. Cribble actually has a universal agent that you can use to replace various agents if you'd like to, but you can also just use your existing agents and forwarders and point them at us. This allows you to collect the data once. Being able to trace data through an organization is going to become increasingly important as we deal with AI and the potential for data to spin out of control. So when you collect data once, put it full fidelity into object storage, first of all, your auditors will love you, right? Because no matter what happens, you always have a full copy of the data that they can go look at that has not been touched. The other nice thing here is that then you can start tracing that data. So every time that data moves, you know exactly which pieces of it are moving, exactly where it's moving, and you're only moving the pieces of that data that the platforms you're sending it to actually want. If your SIM only cares about 35 lines in a firewall log, don't send it 235 lines. Not to call out Palo Alto, but firewall logs are pretty notorious for this, right? They have these giant headers in them. They have like 8 timestamps. Half of them don't have a time zone associated with them, so they're useless. So one of the great things that Cribble Stream does is you can literally standardize every timestamp in your organization to UTC. And from a data scientist perspective, when we're talking about lateral movement, milliseconds, trying to make anomaly detections, this is critically important. All right, we're going to skip the demo because I'm sure you guys have all seen enough demos today. But I would be happy to take questions or criticisms. Dad jokes? Anybody? No? All right, so I want to go back to generative AI because I get a lot of questions about it, so I'm just going to throw a couple tidbits in here in terms of my kind of where I see this going. So I think right now a lot of generative AI and large language models are really kind of a solution in search of a problem, right? We've all seen that there are some ways, all right, one of the reasons that I'm not a data scientist anymore is, to be honest, I'm a pretty shitty developer. So I am terrible at commenting code. And it's not because I don't love the people I work with. It's not because I don't want them to know what I'm doing. It's just because when I'm in the zone, my autistic brain is just like, right. I know what it's doing. I don't need to do that, right? So we are seeing a handful of novel areas where generative AI is actually making a massive difference for security teams, and this is one of them. Writing regex expressions is a lot easier with AI. Things like translating natural language to query language, right? So my husband was actually showing me the other day that he was writing Excel, really complex VBS queries with AI. So these are some of the areas where we're seeing real opportunity. And I think if we start to think about the kinds of data volume that we're going to be dealing with when we start dealing with large language models. Really, because what's happening, right, is we're seeing lots of large enterprises starting to try to stand up their own large language models. And you need a couple things to be able to build your own large language model. First of all, you need to be doing a really good job categorizing your data, because the biggest challenge you're going to have is keeping shit that should not be in that large language model out, and then finding and removing things that are poisoning the well. And this is becoming a huge challenge for OpenAI and all of the other large language model providers. So from my perspective, the ability to effectively identify your information on the way in, I think, from a GRC perspective, data classification is about to become its own industry, because unless you are doing a good job categorizing the data you're bringing in, you're never going to be able to apply data science to it. So I know this is kind of a tangent, but I know somebody's going to ask me if I don't mention it, so feel free to come out to our booth and discuss this with me at length. I have many opinions on it, but I do want to say that I am very optimistic in the fact that I think generative AI and the ability to translate natural language to code is really going to reduce a lot of the barriers that are keeping us understaffed in security, because instead of having to teach my engineers 15 different code languages, they can literally just say, I'm looking for this, and find it, right? So I think it's actually going to do a lot of good, but getting our data house of cards in order is going to be essential. So, no questions? I must have done such a good job. Awesome. Thank you so much for having me. Hopefully I'll see you guys afterwards.